All right.
Let's do it.
Welcome back, everyone. It's another week of AI that works. You've got myself, Vaibhav, and my co-host Dexter. And today, we're going to talk about a topic that I think is a little shift from what we've been talking about in a while. We're going to go back into the depth of models. For a long time, we've been talking about concepts, context engineering, and other application level stuff. Today, we're going to go deep. We're going to talk about multimodality. There's a lot of models now. Models support APIs take PDFs, APIs take videos, APIs take audio, APIs take images, APIs take text. How do we think about that from a foundational level? I think is the goal of what I would love to talk about today. Dexter, does that sound about right?
Yeah, I'm looking forward to going under the hood and looking also, I think we talked about it this time going into some of the more full stacky multimodal experiences like ChatGPT image gen or like the Gemini PDF parser and kind of just looking. I know you're spent a lot of time understanding how those things work under the hood. So learning how to best implement those things, I think could be really interesting.
Yeah, I think let's just start off with something really, really basic. And we're going to do a screen share, but before I do that, I'm going to make sure that I have access to the whiteboard. Um, Dexter, can you give me access to it really fast?
Oh, did that not work? Hold on.
No, it didn't. But I think what I want to start off with is how many of you in the chat, and you can raise your hands, type in chat, whatever you want, actually use multimodality it with models today, beyond just text? A couple people. Um, it sounds, how many of you trust the multimodality of systems as they work out there? Hit or miss? That's generally, some people say yes. I think generally what I have seen with multimodality is it's definitely gotten better from how the systems work to how they used to be when they first came out. Models are, in my opinion, like in front when it comes to OCR, there's no better OCR system than a multimodal LLM. Those are state of the art. That doesn't mean that you should only use L1s for OCR. I think one of the experiences that I remember the most is when I worked on Face ID. Uh, when I first got into there, I came from a very different background than a lot of other folks. I come from a background where I think of, well, I used to hate machine learning. I don't really believed in it for a long time. I came from geometric. I was like, we're going to use math to solve all the problems. And math is correct because math I can see, I can understand. These multiplications that somehow make valid data is like, I don't even know. Like, I don't know what to do with it. And my brain didn't really compute. So I just ignored it for a long time. And every time someone on my team said we should use not LMs, like transformers or CNNs or anything of that sort, I'd say, nah, let's just do math. And the people
Just
that I
do it
learned from,
deterministically and not do the like back propagation and machine learning thing.
exactly. And we used to do all this pre-processing. Like we take these images of faces and like items, and we'd say, okay, let's use math to find contour lines. So we could find like you see the wall behind me. You can find contour lines by like tracking down like contrast ratios over here. And there's a lot of math you can do to like make contrast more applicable and everything.
Oh, like looking like from pixel to pixel and almost like you would draw like an elevation map with like rings based on similar
Exactly.
elevations. The same algorithms
Exactly.
you can use to, okay.
And there's all sorts of algorithms you can do here to go find that, like LCN, other things that you can go do. We do that, and then we'd say, okay, now let's make sure that we hide away pixels that are really far from the edges so the model has cleaner data to train on. We were trying to pre-process the data before getting into the model. It turned out that was dumb, and the better thing to have done would have been to just collect more data and train a bigger model. We were wrong. Models are really, really, really good. But I think there's a thing that a lot of people forget, which is when you try and do models, people try and do everything in models. And that's not to say that that won't happen, but it's really good to understand the constraints of a system. If I'm trying to build a, like, let's say a URL encoder where I take a URL and I encode it into like a string that I can actually pass to a model, into a website, you're right. I can ask an LLM to go do that. I can even ask an LLM to generate random GUIDs or UUIDs for my database entries. Should I? No, it's the wrong tool for the job. And it's the same way with like VLMs and image processing pipelines. Can you trust AI pipelines that use images? 100%. Will you trust them a lot more if the images have backed data with verification? 110%. And when you're using AI, that's what you need. You need that 110% guarantee to feel really good about it. So, and I think that's really what I want to talk about. How do we get to 110% guarantee? And I think the Excalibur is working and my stall time worked. So let's screen share and go do that. Dexter, do you want to screen share by chance? Or I can
Sure.
actually, better.
I
Oh
can do
wait,
it.
I don't,
You should screen share.
I realize I don't have two screens today, so I will just screen share. As per usual, if you see anything you're not supposed to see, please let us know so we can edit it out of the YouTube video. But otherwise, the game is fair play. So PDFs, multimodality, and vision models. Let's start off with a really, really simple problem. Let's say my goal is to take a bank transaction statement and extract all the transactions out of it. The bank transaction statement is going to come in PDF form. Problem with PDFs is models don't actually directly understand PDFs. So let's understand what a PDF is. A PDF is going to be multiple pages. So I'll actually have multiple pages.
And just before we get into the pages thing, like PDF under the hood is basically a bunch of XML, right? It's like metadata, it's like characters and metadata about how they display, right?
I think so, but I also think the way that PDF is done is really PDF implementation specific. Because like sometimes they
Yeah,
load it purely as an image. Some stupid PDF systems don't actually like make the
that's right.
docx kind of format, and it's a pure image saved as a PDF.
Yeah, right. When you scan pages from like a link or something, that's you end up with. Oh, can you hear me okay? Oh, I lost all my audio. Sorry, one sec, folks.
Oh, there you go.
Hear you. We lost five out there. He's back.
Okay, there we go. Sorry. When you like scan a book in the library and you get the PDF, or like when you're in college, you have those like PDFs that's just like literally pictures of the book text. It's not actual renders as text.
Exactly. So like you run into all sorts of problems like that. So like how do we go and do this? So I'm just going to break this problem down and just talk about PDFs as PDFs first. And when I think about PDFs, I'm going to stop thinking about it PDFs. I'm going to just think of it as pages. The simplest thing you can do is not think about like pages. Take your PDF, toss it to the OpenAI or some other API point that takes like a PDF object directly. And they take it as like a base64 or as a what's the other options they do, or like a file URL or something. And you pass it in, and the model basically just spits out whatever you want and injects in part of the prompt. Now, a lot of people assume that they train the model on PDFs. I probably wouldn't assume that personally, because if you actually go read the documentation about most of these systems, most people, what they actually do with PDFs is they do the same thing that we were going to do, which is we take every PDF, we turn into pages, and then OpenAI tells you this directly. What they do is they pass in the pages as images plus OCR text. That's all they're doing when you pass in the image as a PDF. They're converting the PDF from pages to images and then adding the OCR text as a part of the prompt. I think Gemini does something similar as well. And I believe Anthropic likely does something similar as well. That's not to say that this method is good. That's not to say this method is bad. All that you have to know is that someone is doing some work on your behalf to convert it into the API format that they want. Why does that matter? Well, it's because the way that you pass in the PDF, the way that you convert a page into an image can vary a lot with PDFs. You can choose what ending resolution you want the image to be at. You might have PDFs of extremely long shapes. Anthropic might end up cropping it by accident because they
Right,
need
they
to
chunk it up into square regions of the thing and send us all as separate images, maybe.
exactly. Like you have no idea. And it might be good, it might be bad. But if you're operating on a standard 8 by 8, like A4 page, you're probably fine. The minute you start skewing from that, you have to remember that people are probably not doing the standard stuff and you're not doing standard stuff. So using the standard API is probably going to hurt your performance. And I think if you actually look at the Anthropic docs, images docs, and I think I was reading this and I've been surprised by how few people actually read this, which is there are aspect ratios that tell you the maximum image size. And I constantly see people passing in images bigger than this size. And I'm like, okay, that's okay. But you gotta also remember what people are going to be, what these companies have to do if you pass in an image that doesn't meet this size. They're gonna have to either crop or resize your image to scale it. If your images aren't exactly one of these ratios, you're probably hurting your performance
And
because
that's because the actual uh encoding layers on the transformer can only, or on the model can only handle like images of certain sizes, and they basically, it's like cheaper for them to pre-process to a set of specific sizes than like train the model to handle every single size.
I suspect it's just what they've trained, to be honest.
Yeah,
And like, these recommendations probably just come from training. I don't know. I don't work at these model companies.
yeah.
Just to be very, very clear. And with machine learning, like remember, everything is just see where the wind goes kind of thing. And it's hard to know exactly what things are happening, especially in closed source systems. But like my intuition would really just urge me to believe that like if they recommend certain image aspect ratios, like models perform based on training data. So like if they've only trained on images of this data set resolution, the model can probably infer a lot of things. But if 95% of the data is this, it'll probably just work better on something like this.
And I'm gonna guess that where we're going with this is basically like, if one of the takeaways for me so far is like, if you're going to hand an image to the model provider and let them basically be the ones that do the resizing for you, you might as well do the resizing yourself so you have more control and more kind of determinism around like exactly which region of the image is there or exactly how it gets cropped or whatever.
Yeah, and at least I think at the very least, knowing it's like what we say with when using the best model, use the fastest thing first, not in terms of speed, but the thing that gets you up and running first. So like what do I do? We use big models. We use GPT-4o, we use O3, we use Opus, we use these bigger models at first. And then we realize that we have a performance problem or a cost problem, so then we bring it down. I actually would advise the same thing in these image models. Know that if you don't know that the model providers are doing this, then you get stuck. But if you know that they're doing this, then you can do the standard thing, just dump it into the model providers. And if it doesn't work, then we'll pull out tools out of our tool belt and apply what we know by understanding the system and do better than what they do. And that's usually my advice. But before we go into this and like go really deep into how to solve this exact problem, because this is the one we'll be coding today, I want to spend a little bit more time talking about how multimodality actually works. Um, anyone have a hunch about how images work differently than text in multimodal systems? Let's see. You can if you guys have thoughts, by the way, feel free to raise your hand. Just come on mute and let's. I'd love to hear someone's take. And remember, no one actually knows the answer to this, so everyone is speculating at best. So I want to call that out. Dex, do you have thoughts?
Um, Probably, but they'll probably make me sound pretty dumb.
Well, I'm gonna sound really dumb when I start talking. So
I
it's like,
mean, I guess my rough understanding is essentially similar to how a model can embed text and like take a bunch of text and then apply attention to it and build a set of vector tokens that represent meaning. There are similar kind of encoders, decoders that can take an image and turn it into a vector that has that same sort of meaning.
yeah, I think that's basically it. I think the key thing that I think about is like in the end, all we have is tokens. The LM architecture doesn't fundamentally change when you toss multimodality into it. It's still just tokens. So when we go and use these tokens to go do something, the way that I always look at it is with text, we know how the tokenizer works. So if I go and show where to go, ah, OpenAI tokenizer, and we look at this, you'll notice that you can like actually see the tokens that are being typed in, and OpenAI even shows you this. None of the multimodal providers will show you their tokenizer except perhaps the open source ones for how image tokenization works. And I suspect that's because it turns out images are much, much harder to train, and the vocabulary there is much harder to like generalize on like what these token IDs mean. Or maybe there's a novel technique that I don't know about or any other such thing. But no one so far is really revealing this. So, and that's also why when you look at cost, everything is always just an approximation of cost, and there's no way to actually go and predict tokens as well. And it's always an estimate. That's because I bet people are doing weird things with tokenization under the hood that for images to make them really work really, really well. Like they probably do image compression. They probably do all sorts of like taking out background images out of PNGs might be treated differently than like JPEG. Who knows? So what I would think about when you have an image is, as a general rule of thumb, without knowing any specific tokenizer, we can think about what tokenization means. And all tokenization means, and I do not want arrows, I want no arrowheads. How do I get rid of arrowheads? Oh, I have to do L, sorry. An image gets broken down into tokens like this. And this is the most simplistic version that you can do, is you just break it down to a grid, and you would take each grid cell, and each grid cell will become a token of some kind. The other thing that we can do is, if I'm doing this, I'm going to run into problems. Like, for example, if I have text like this, the horse is lonely today. Clearly, I'm going to run into conditions where things that live on the boundary of these systems are just going to perform worse than content that lives within a single cell, because it's harder for it to generalize, especially if I'm asking for like really, really summarized information. Because in order for it to summarize information across the whole image, it's going to have to not only read every cell, but it's going to have to draw inferences between how each cell connects and how inference is done on each cell. Did you have a question, Jack? Okay. On the other hand, if I have a cell that has a bunch of small text, like the horse is doing fine today. I don't know why I'm talking about horses. I don't even like horses. And all of this lives in a single cell, then we'll run into a different problem, which is I've now done compression on the token side. So where one token now has a lot of information in it. So while I do really good summarization tasks, I'm going to do much, much worse at like detail-oriented tasks. Like if there's like two whole paragraphs in there, I've just lost information. You can kind of relate it to like the DRM concept that we were talking about in the last few episodes, where like you could have memory for the month, for the week, for the day, and for the entire chat history directly transcribed in, and they provide different purposes. But the tokenizer for an image is inherently going to end up doing that accidentally or on purpose. It's really up to you. So
the Claude thing was made it look like 750, like they're divided by 750, which makes me think that it's the regions are around 750 pixels, right, per token.
Maybe.
And so you could easily have a whole sentence in 750 pixels.
Yeah. So like I don't really know, to be honest. Like maybe that's just like a raw math that they did. They might have like like when we do like
right. It's not they're not all going to be the same size, right? There's something in there that is basically chunking up the image in a smart way to try to make the regions into like contiguous bits, I would assume.
Yeah. Like the fact that the strawberry is red is 4 tokens is like no one would know the word strawberry is I didn't know the strawberry is going to be 1 token in the tokenizer. Like, but it is. And it didn't used to be. It used to be 2 tokens. I can find the other token. There's some other tokens where it used to be as 2 tokens or something. And I know like strawberry without a space is definitely 2 tokens or multiple tokens, because like the lack of a space at the beginning changes the word. But
oh, wait,
yeah.
That's crazy.
Yeah, people got to know tokenizers. But the whole point here is like, and by the way, you can see how this fundamentally changes the meaning of the sentence to the LLM. Not to us, but to the LLM it does. It means something very different. And this is also going to be true for your images. So when you talk about like what resolution should you use for your image, it's not just a question of like what resolution do I use and what's the highest resolution I can get. You also have to think about what is the task I'm trying to do. If you're using a very detail-oriented task where you have to pull out all the pixels in it, you might actually benefit from not just OCR, not just like high-res images, but breaking down your image into smaller images that are all high-res individually, because you might just get better extraction out of it. The same, on the other hand, if you're doing a bunch of summarization tasks and you don't want details in the image, like you're doing like a, where is this? Where's Waldo task? Like, let's just take an image of Where's Waldo. If you're doing this kind of task, You definitely don't want this going in as a single image. Just do Where's Waldo. The LM just can't do that. And this is equivalent to how many R's are there in strawberry? That's the equivalent problem, I think. But if we were to break this image down into tons of tiny images and upscale them, the LM is much more likely to be able to solve Where's Waldo.
It's funny. I definitely saw this picture before. Waldo's right there because someone actually did the example of passing this image into an LLM and the LLM finding Waldo. Did
Yeah,
you see that?
I have no idea where Waldo is. I don't understand this. But like this is kind of what how
Oh,
I
you
would
missed
think
it.
about LM. And like is that where it is?
Yeah.
Oh, I found him. Nice. Yes, I'm a really shitty LM. But I think the point still stands. When you think about images and think about video, just remember this whole game that all LMs do is always tokenization. The fact that OpenAI and everyone else just does something with like PDFs with OCR is like if you just go to how they do it, I think they tell you this in your document. They tell you all sorts of things, and they actually tell you exactly what they do in the PDF documentation. I can go find it in a second. OpenAI PDFs. Is this it? Yeah. And you can just go read this, and like what you'll find is they basically just convert the PDFs to images and they process that in. So they're not actually training the model specifically in PDFs, as far as I know. They train this, they just use they use the multimodality capabilities of the model and go leverage that. And sorry, I'll pause. I'm gonna catch my breath really fast. And oops, wrong thing.
Yeah.
So when it comes to extracting transactions out of PDFs, how would we go about this? Well, I think the simple thing is, let's do the very, very dumb thing. I take the entire PDF, I toss it to a model, it gives me the answer, and then I just say, whoop, I tell the user yes. And here's the answer. The most complex, and now let's add a little bit more complexity. I take the PDF, I toss it to the model as is, and I have it, instead of answering the question, I first have it extract data based on the type of PDF that I know it is. I know it's bank transactions. So what I will do is I will extract all transactions out of this data. And then I'll feed a different prompt with this question and all the transactions, and then answer the model's question. So I'm simplifying the problem for the model. And you've seen us do this a few times with a bunch of other problems where if the problem ends up being too hard, break it down to two problems. And now we pass the problems down. This still might not be good enough because we have two problems. The LLM might hallucinate at the point of transactions, or it might hallucinate at this point of actually answering the question. The harder one to correct is the transaction ones. If we can get this data correct, this thing will probably work. Because
You're talking about
LLM,
just like breaking down the problem, basically,
yeah.
and being able to test and optimize each part separately.
And then also understanding where the failure point is. Like, I bet that's like 80% correct. And I bet I'd be surprised if LLMs, given correct data, are going to be really bad at questions like, what's my ending balance?
Right. Hey, here's a whole blob of text in JSON. Find one of the values in it and
Yeah,
spit it
like
back out to me.
it seems unlikely, but I think this thing is going to fail a lot. And then because of that reason, it's going to feel like oops.
Oh, you leaked your Chase code.
Oh, it's okay. I'm about to show base PDF, so it's okay. It's gonna feel like this, so it's gonna feel worse. And if the back half is 90%, it's gonna feel even worse. It's gonna feel like a 70% pass rate. But really the problem is the first one as a whole is not really good. So if we can bump up both of these to 95%, we'll just feel better. So let's try and go do that. Well,
And it's
one
a
way,
really interesting concept I think you talk about a lot, but doesn't get really like explicitly stated, which is this idea of basically like if you have a 75% success rate and you run one, if your pipeline has one query, then your accuracy is 75, or let's say 90, right? So like if your accuracy is 90% here, oh my God.
I got some for you, Dexter. You can just take a screenshot.
All right. Just paste it in.
Oh, what the heck? I can't open it. Yeah, I'll paste the screenshot in. I think what you're trying to do is somewhere in there, is this. When you have a pipeline that's like 99% accurate and you have like 20 steps, it ends up behaving like a pipeline that was actually like 80% accurate. When you have a pipeline that's 97% accurate and you have 20 steps, it behaves like a pipeline that's 50% accurate. And it's really, really hard to understand this concept. It doesn't feel intuitive, but it falls off really, really fast. And just like a 2% difference in your pipeline accuracy is a 27% difference at a 20-step mark. And that is like not intuitive at all for a lot of people. But this is why agents feel like they don't work, because agents typically have multiple steps and people are like, what the heck? It's not working. It's because of
Damn, this should really be the 12-factor agents presentation. This is such a dope graphic. Yes, this was what I was trying to draw.
Yeah, you can add a screenshot of this if you want.
I did. It's on the whiteboard.
Cool. So when we do this, let's see how we can make transactions better. Well, we can make this really good by saying that we know that LLMs are going to be, if it's extracting 50,000 things, it's going to get one of them wrong. Almost definitely. It's just like probabilities, right? It's the same thing. Probabilities matter. If it's 99% accurate on extracting everything and has to extract 67, like 20 things, it's going to behave like a thing that's 80% accurate extracting those things. So let's change that and say what I will actually do is I'm going to have it extract two things. I'm going to have it extract both the transactions and the summary balance as a whole. And then at the very end of this, I won't feed this directly into my system. What I will do instead is I'm going to run a different loop that's just going to be basic math that says, does the summary equal the sum of transactions?
So this is the runtime evals, basically.
Exactly. I'm going to write a runtime eval that validates this. If it doesn't, I will try and find where it breaks. Like, where does it actually break? Does it break on page 1, page 2, page 3, page 4? And then I can send just that page back to the model and have it go and run in this loop until it meets some constraint that I've defined. And even better would be if I can do intermediate checks within each transaction as well. So sometimes like bank statements have like a before and after balance for every transaction. I can check that balance as well. So if that balance individually ends up being wrong, then what I can do is I can go to an LLM and say, hey, the balance for this purchase entry seems wrong. What is the right answer? And now the LLM is going to focus all of its attention, even if I'm giving a bunch of tokens, only on the two that really, really matter, because LLMs are pretty good at generally answering the question that you want. They're just really bad at like answering every question correctly all the time. So you'll be like, okay, I only need to look at these two tokens to answer the question about that sub transaction. I'll answer it. And we update our data model, we run a loop, and we're getting this going. So you can kind of approximately see how this loop would work. And at some point, two things will happen. Either this thing will work and I'll get things where all the constraints are matching, and then I will send it to my prompt. Or it won't work, in which case maybe I'll build a human in the loop system that sends us out to like someone that like literally reads these transactions manually and just corrects the right output. I record exactly where it messed up, so I have good understandings for my engineers to understand where the failure points are, and I send it on to the next pipeline. If this is a completely real-time app, then I will literally just tell the user that someone who finds the failures where I can't correct for it anymore, I'll literally just tell the user, I found these 4 mistakes. Can you help me with this? Or I'll tell the user, sorry, I can't answer you for these questions. I seem to be having trouble understanding these four data points, and I seem to have mathematical errors in validating them. So I can almost build it into my UI, into my process, and in different works of the way, so that my end pipeline, it might not have 100% coverage on the data, but for all the data it has coverage on, it will be 100% correct. Does that kind of explain what I'm saying?
This makes sense that like the human here could either be like the builder of the app or the user of the app and like soliciting human input from one or the other of those.
Exactly. And then we know LLMs are really good at answering questions given data. The hard part is getting the right data in there. That's all what context engineering is. So we're doing some pre-processing to get the context engineering data into there.
Okay, so in both these cases, whether we have works or not works, you have validated transaction data.
Exactly.
And basically, you can have really, really high confidence if the LLM's doing its summing, if it's doing all the things, and then your deterministic code is doing all the sums, and all the sums work out. You are very, very confident that, like 99.9%, that this was extracted correctly.
Exactly. And obviously they can make a mistake. The bank itself could have typed out the wrong digit and written
Yeah.
out the wrong thing. Like there's tons of mistakes that could have happened. It's not to say this is perfect, but it's all cross-checkable and verifiable. And I think that's
Yep.
as good as you can really do.
Cool.
And I think this is how I think about this. Now, I'm going to talk about a lot of techniques to make this part better today. We're not going to talk about this at all. I only really want to talk about this part. And we're not even going to talk about this eval loop. I'm really going to focus on this
Because
part.
we already talked about the eval loop, and like we'll
Yeah,
link
go
to the
watch
other
the evals
episode where we
video,
talked about the
episode number
evals.
5, if you want to see it. We talk about that in a lot more detail. Like that stuff isn't going to be that hard. It's different, and you might as well learn from there instead. Today, I really want to talk about this image part a little bit more details. So I'm going to start off with just showing you how we would start with this problem. So I tried to do something. I started actually writing some code. I wrote some code earlier. I apologize. I typically try and do it live on the fly. PDFs are funky, so I wanted to make sure it really worked. And I wanted to make sure the data I shared was perfectly good. So I'm going to start with just sharing what the data is. Open on, reveal and finder. Okay, so first things first, this is my bank data. If you see something that is really PII, please tell me so I can crop it out and make it go away. I think I took out everything that was relevant out of this, but I do want to add a disclaimer. This is my personal bank data. Let's not let me get pwned.
Yeah, please don't steal Vibov's identity. I need him to keep doing podcasts with me.
So I took out page 1 that had a lot of PII, but page 2 has less. Page 3 is basically just like account transaction history. So like things that were bought. Has a bunch of stuff on there. It's got some fun little transactions from Canada. It's got some transactions in Seattle. I live in Seattle. I guess you doxed me. And then we've got some other things about like interest payments. I don't pay interest because interest is a scam on credit cards. If you pay it, you fucked up. I'm sorry. And getting out of that situation is really hard.
Oh, are we gonna pivot this into a financial advice show?
No, just don't get a credit card with interest rates. And like, or don't pay interest on your credit card. But this is a PDF. And I want to call out some nuances out of this PDF. The first thing you'll notice is that these pages are not standard pages at all. They're like slightly longer than normal.
Nope.
So the second thing that you'll notice is that these pages have headers and that they have footers. And like that might confuse the model. It might not. I don't really know. It has these summaries, but overall, it seems to mostly be correct. It's interesting because I don't know what the actual dollar rate here is. Like, is this Canadian or is this USD? It should be USD, but you can see how there's an ambiguity here to anyone that's just glancing at this without knowing. It seems that the conversion rate is defined here, but it's impossible for someone to actively know for sure that is the case unless they look at the details of what this is doing. There's some inferences that we're making.
So I'm gonna just real quick infer, just looking out loud, is you have 940 times 0.778, and I assume that is 732. So that would be
I
my
think
guess,
so.
is these are USD and that these are Canadian. But
Well, you got a
again,
great example too, where the top, that like last line on the page above, that like that 234 is actually the 3, like that's transaction split
Exactly.
pages.
Right? So we're going to run into all sorts of problems here. If we were to transact this data out of the model, like I think we could all believe that this thing might not be perfect. But let's
did you
do
go
the
to Banff?
I did. Banff is awesome.
Damn.
I went on a backpacking trip. We did like 55, 70 miles or something. It was
Wait,
really,
that's sick.
yeah.
Let's put your backpacking photos into the multimodal model. See what no, I'm just kidding.
I'll put them
Sorry.
up.
Continue your live coding.
They're from a time when I was less fat. But okay, so I wrote the code already for this, but we're basically gonna have a function. It's gonna have a content. Content is gonna be a PDF type. We're gonna return a transaction array, which I've already defined over here. It's name and amount. Amount is a float. We're gonna use a GPT-4o mini model. We're gonna write a really basic prompt, extract all the transactions from this content, and the content is just gonna be that PDF that I passed in. Let's look at the prompt. That's the first thing to do. The first prompt is just going to be a system message, as expected, just comes from here. And the second prompt is going to be just a PDF. So like we have the PDF, we can make sure that it's the actual content that we have. Seems like this is probably good. Let's run it. It should run. And sorry, I have to move the letters. And it's going to run and do its thing. Sorry about the blinking. Streaming is, as it turns out, partial data is very, very hard. But it will become stable and it'll go out everything. While this is running, let's do the other thing. And this to the next part of our task, which is like understand our data. So is this thing even before we can do anything, we have to count how many transactions there are. If we don't count, how can we actually know? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 1, 2, 3, 4. 54 transactions. So at the very least, I know I expect 54 transactions out of this. Cool. I already know the LLM messed up. It only got at 48 items. So that's my first validation loop. Like it's
I think it was
guaranteed.
the page boundary.
I have no
You
idea.
have one that spans a page boundary? Okay, cool.
We can just check, right? So like we just take this data out and we just look at it. We know that the things that are hard are this one. So like to see if we got this one. Blinky app QC. This is 234. It got 311. Why did it get 311? I have no idea. It clearly just hallucinated that thing. Oh, there's two of them. Yeah, it just got, that was just wrong. There's
Were
no
those
way.
ATM fees?
Huh?
Were those ATM fees?
I have no idea.
I
To be
think
honest.
Blinky, those are $3. I bet that's
I have
sorry,
no
keep
idea what
going.
it is. Chase Travel right over here. It's 347.90. This one pulled out correctly. Moraine Lake 732. That pulled out correctly. It just dropped data right here. It dropped the one at the boundary. So we know we at least missed one. And I think the first thing that you're noticing that I'm doing here is like I'm just understanding what the model can and cannot do. I did the dumb thing. I tossed it at the model. I said, figure it out. Turns out the open API spec is probably not the right way to pass in a PDF that's a spend bank transaction because a naive thing doesn't work. Well, the next thing I can do is I can do some images. I can convert the stuff to images myself. And then we can just go solve this problem. Well, I think the biggest problem that we'll run into is actually headers and footers. So I actually started writing some of this code. And a lot of people don't realize this, but it's actually really easy to detect this stuff. Let's think about what it means to find headers and footers. Well, the first thing we'll do is we'll convert every page to an image. Once we convert every page to an image, I'm going to write a really, really basic prompt. And this prompt job is only going to be like function has transactions, page, image. Right there. And that's all I'm going to do. I'm just going to ask this. And because this is such an easy problem, I'm going to use a mini model for this. I won't even think about this. Test has transactions, file, page, and the image I'm going to pass in, I already have all the pages. So I will do /data/ page 0.png, title page. Transactions, page 1, and page 1. We'll run these. And I kind of want to run this test just to make sure the model isn't. Okay, this model is dumb, so I'm going to use Anthropic.
Yeah, it's weird, especially when you get to like processing. I've had a lot of issues with getting 4.0 and 4.0 mini to process like ID cards. If you want to like test extraction on like
I
your
know,
passport or
it's so
something, it
annoying.
like refuses to do it, which makes sense. The odds that you're doing something naughty is pretty high if you're trying to parse an ID, but
Yeah,
let's
so
see if
I'll
this
just fault the
works.
model. Oh, I did the wrong thing.
You did the long
Yes,
one.
this page is transactions. Oh, yeah, models don't like answering in Boolean all the time. I've noticed that. So like, yeah, answer. I'll usually just do this kind of thing. And that helps the
Yeah.
model because they hate answering with just true and false.
Yeah.
I actually want to make that yes or no, and that actually usually works better. And now it said the answer is true, and this makes sense because Does it make sense? This makes no sense. What is the model doing? Okay, it's a dumb model. Let's use custom
Finance
model.
transactions. Okay, let's try it.
Okay, a smarter model seems to do better. Does this page have transactions? Does this page have financial transactions for a specific? Does it have financial specific financial transactions, credit slash debit? That's a type. Credit, debit, other. And I will just make this a array. And specifically, I only care about credit or debit. So I'm actually going to help the model do even better. Is like now even the dumber models will probably do better because it will just tell me what type it is. So if I ask like haiku, does this have right page type? This is probably going to work. Uh, uh, actions, cover page, non-financial. So I'm actually going to, and you're watching me prompt engineer on the fly because what I'm really trying to do is I'm trying to understand what this page is doing. And this page has transactions. Currency. Does this actually? I mean, it might.
I mean, it has language about transactions, but it doesn't have the transactions themselves. I would almost say like transactions with amounts, because I don't think this has amounts in it.
I mean, it might. I have no idea what this page has. Yeah. It does. I mean, it has information about financial transactions. And does it? I mean, I should just look at the data really fast. At this point, like, there's two things that could go wrong. Oh, I mean, it talks about payments, how to avoid payments on interest charge. What would I call this page? Like a what's the I'm looking for?
Transaction rules.
Let's try this.
But you get the point. Is like extracting the data is a really like clean way to like look inside what the
Cool.
LLM is seeing instead of just pushing in the image and your prompt and being like, why the fuck isn't this prompt working?
Well, at this point, I kind of solved the problem for myself. The number of transactions is 0. I don't even care if the number is correct or not. It really doesn't matter. And I'll run this thing and like the number of transactions 20, it doesn't matter. The point is what I'm going to look for is page type transactions and number of transactions greater than 0 is going to filter my images for me. So for every image where I have more than 0 transactions, I'm basically going to run a function. Def take page image image what I'm going to say is I'm going to say b dot, they're not done b yet. Import b. I'm just going to take the page. I'm going to say b dot extract transaction or has transactions. I'm going to pass in the page. I'm going to say like def res equals this. If res dot page type equals transactions and res and number of transactions equals 0, then I'll process the image. Otherwise, I won't. And now what I'm able to do is I'll go do something in this scenario. Otherwise, I won't really do anything down here. Now get pages, get data. Once I have all the pages, what I want to do next is I want to detect headers and footers. So how do we do that? I think that problem people say is a very hard problem. It turns out it's really, really easy. All you do is you just pick one page to be your anchor page. In my case, I just picked like the first page that has transactions to be the anchor page. And I just do a diff on it. And you can see what this does. Let's see if I can save the diff. And there's a lot of Python libraries, TypeScript libraries. I'll do this for you. And you can just see what I did. I'm able to remove the top level thing because all it does, it takes it turns the image from from RGB to black and white and just paste it on top of the other image. Any place.
And then what it zeroes out any pixel that is exactly the same between the two.
That's it.
Sick.
It's really it. And then After you do that, you basically find all the places where you have diffs. And it should become almost perfectly evident where your pages are and where you have similarity. And it becomes really, really easy to go do this. But then what you can do is you can do the next thing, which is you can take the diffs that you have and you can say, okay, let me scan every row in the image. And wherever I have exactly the same pixels, I can assume that that is common across pages. And you'll notice that I have some stuff at the top over here, some stuff at the bottom, and then I get some stuff over here and I get some stuff at the bottom as well.
Looks like this is mostly just white space that matches, right?
And so exactly, it matches a lot of white space, but it's also matching top and headers. And I was really confused when I looked at this image. Why does it match this top part of this page, but not top part of the second page? Well, it turns out when you look at the data, you quickly realize, well, one, this page gets ignored. It doesn't matter. This page is our base page that we use as our anchor. Page 2, for some reason, doesn't actually have headers.
Huh.
Right? Page 3 does. And like this is like the randomness that you deal with in the real world. But when you deal with this problem, you quickly realize, okay, it sounds like while page 2 and page 3 don't have headers, page 3 and 4 both have headers and footers. Pages that are like page 2 both have footers that are exactly the same, but the header is not there. So the header is either exists or it doesn't exist. So what I can do is I can write a really, really basic heuristic that says, given 10 pages, find the headers and footers that are common on them. And some pages may or may not have a header. But once I find a common header, I'll just take that header and I'll just ask an LLM, is there anything but the header missing from images that don't have that header? So I will literally go ahead.
Okay, so there's a lot of stuff happening here. I've lost a little bit track of like the steps in the order you're doing them, and I'm wondering if either we can go through the code or if you want to whiteboard a little bit more to kind of show how all of these different techniques like work together and in what order and which ones are kind of mutually exclusive versus the ones that work together.
Let's do that. Let me write some pseudocode. That's probably the best way, actually.
Cool.
So I'm going to start writing some pseudocode. So we're going to take this. We're going to say def, given a bunch of pages with analyze pages with transactions. And there's going to be a list of pages. What we're going to do for every page is we're going to pick our reference page, which is going to be image 0. We won't even think about it anywhere else. And then for every page for other in image 1 to on, what I'm going to do is I'm going to compare pages to find a shared headers, footers. And then after I find shared headers and footers, I'm going to say
what is the type of shared headers footers?
Headers, footers, and you can think of this as basically a list of y coordinates. It's a y1, y2 list. Right.
So it's a list of like horizontal slices of the image that contain headers and footage.
And this is just semantic information that we all know in the idea of headers and footers. It's like headers are generally across the whole head and across the whole footer. And this is semantic.
If one horizontal part of the page is header, the entire row of that image is part of the header.
Probably. And like
almost always. I'm happy to assume that.
Yeah, and this doesn't apply in all cases. Like if people are doing messed up things, like taking pictures from their phone of tilted bank transactions and like uploading them, like you will run into problems. But we can detect that by saying that we will just apply a constraint on the system that this is only images that we think will abide by this rule. So we're gonna do headers and footers. And because we're reading bank transaction statements, we're gonna assume that most of the PDFs are coming from PDFs directly generated by some bank. Most of those systems will have standardized headers and footers. So I'm going to find the header and footer of every page. And I'll just append this into a list. So these are all our candidates for what may or may not be headers and footers. Then I'll do find most common header footer. Most common. I won't even do this. What I will literally do is I'll like ask LLM which one this is, and I'll give it like a bunch of pages as an input.
Yep.
right? So I'm not even thinking about this in the same way as that, which is like, screw it. I could do an algorithm, but like, let's do the dumb thing. Let's just ask an LM which of these headers and footers makes the most sense. And now we have our most common header. And
So the headers footers is a pair of XY coordinates. Is the LM going to be able to figure that out? Like what it
I
means?
will, you'd be surprised, is kind of what I'd say. But I think it would do fine. If that doesn't work, I'll literally send it in the boxed entries of these headers and footers with the black area with it writing XY.
Okay.
And I'll just like fill that in myself.
Okay.
So
Have
I'll go
you
do that. Go ahead.
have you tried like compared like Gemini's ability for like boxing things? Because Gemini's a lot of training I know for like bounding box detection in this sort of like use case.
We can do bounding box detection, but like I think what I like to think about is just like it's just good to have like practice of tools. I think one of the things that you'll see in a lot of our talks is we talk about like just like general software engineering techniques. This is basically like a leak code problem in the world of AI. And like this is I think for that purpose useful. Gemini is not bad. I know a few people use it for that as well. But I think it goes back to just like knowing that your data is weird. In this scenario, I know my data is weird because these images are just not standard size. So like, even if it is really good, I just want to have a deeper understanding of where I'm messing up because like I want to have a better audit log because of its financial data. But I haven't actually tried Gemini's thing for this task. I do know that the customer that built this pipeline is very happy and it works really freaking well. So this idea is actually not my own original. I am stealing it. I had some of these ideas, but not all of these ideas. But it does
Very
work.
cool.
It's provably working, is what I would say. Cannot share how much data they're processing, but it does work. And this technique works in a couple of other domains, not just healthcare, not just finance. We've seen it work in healthcare and a few other systems as well. But we strip out headers and footers. Now that we find out the most common headers and footers, we literally just like remove mask images, mask image, and we pass in a page, most common header for page and pages, new image equals this, and then process.
Okay, so we could use some fancy algorithm to figure out which of those X like YY pairs were the most common set and like the right overlap, or we could just ask the LLM to look at all the YY pairs and just be like, okay, this is the one, and we'd just start with that and see how that performs.
Yeah, exactly. I'm just doing dumb things, and I think that's
Yeah.
the best thing to do with LLM. Like I can
Yeah,
also
yeah,
ask
use
them
the
how-
LLM to do it, and like if it gets it 99% right, then just leave it as LLM, and if it gets it 80% right, like go write the code. Fine.
or ask an LLM to write the code. They both work.
That's what I mean. Yeah. No one's writing code anymore except for you on this live stream. I assume all of us are just shouting at coding agents at this point.
And now we just pull out transactions. Right? Txn.extend.
Okay.
And
And
now
then
we
you run
have
your
it
other LLM call, that actually like pulls them out of the image that's been kind of masked and cleaned up.
exactly. Right.
It's
Because
all
now
about attention management, right? Context engineering, right? You're just
I'm
controlling which tokens go in.
literally what I'm doing. I'm literally deliberately choosing what tokens go in to the ultimate degree by effectively spell checking my images.
You all thought you were going to get a break from context engineering, but it turns out every episode of this show is actually about context engineering.
Yeah. Now, the next thing that we'll run into is that sometimes, well, actually, I think there are a couple questions, so I'll just double check really fast if there are any questions.
Is it possible to do in-context learning with images?
Is it possible to do in-context learning with images? I have no idea. Probably. These model people are pretty smart. That's probably what I'd say. I don't know. I don't have an absolute answer for that one. To run only if we use this technique, we wouldn't need human in the loop. What is most common header stored as? Honestly, it can just be your header type. It really doesn't matter. You can define header as just like a Y1, Y2 range. You can define it as a proper bounding box. You can define it as whatever you want. In this case, this can be like two things, where header is a header and then like header equals this, and then footer equals this. And there's different ways that we can go about and go do that. And then the next thing that we can go do, there's one more question.
Yeah, one more question is good. Is so yeah, like we talked about doing kind of like runtime guards and runtime evals for like summing transactions. Do you have any sort of like version of that for plain text, like extracting a legal clause from a legal document?
It's honestly going to be really similar to what you just saw me doing at the very beginning of this system. Like when I was playing around with this and trying to make this work, like hash transactions, it didn't actually work. You guys all saw that in real time. It didn't work. And
Vibe evals.
you saw the prompts that I went with. I was like, it's not working, it's not working. So I kept on iterating. I tried different techniques. I said, let me add a page type. Then Dexter was like, try transaction with amount. We tried about 12 things to make this thing work. And we did make it work because it turns out the answer was I both will require a page type and number of transactions. And the mutex of both of those together tells me whether or not the answer has transactions. So
Hmm.
it's going to be the same thing in textual data. Try and understand if you can apply constraints. And sometimes the constraints are not as direct as you can think of. They sometimes require you to do two different things. And being creative with that is the real answer with those things. And then obviously pull data from other stuff as well. Such as like if you're doing medical data transaction, like validate data against your actual database and go do it from that perspective. Now, with that, I want to do the second part is how do you do page over page overlap? Because like that, I think is another big problem. Well, it turns out
Yep.
that's also a really easy problem. What we do is like we'll say related to previous page. Enumerate I equals this. If I greater than 0, we'll ask the model this. And we'll just ask the model like, is this continued from a previous page? And we'll just give it 2 pages. We'll give it the new image. What is this?
Mm-hmm.
Previous image. And we'll just say previous page over there. And we'll just ask it to compare and just say like, does this data continue? If it does continue, what we'll say is like, oops, sorry. Pages equals new image. Per pages, cur CTX. So my current context is going to be just this page that I'm looking at. If it does continue from my current page, I'm going to append the previous page to it. Now I'm going to get the context from like the current context, and I'm going to pass in both pages into my transaction array. So at any given point, I'll pass in both the previous page and the current page. Now, because it's transaction data, I have another bit of knowledge that I have, which is the previous page fully doesn't really make sense. So I will literally crop this page, crop top half.
Oh, you could literally ask it to find incomplete records and then just like stitch those together into their own image or something.
Exactly. And I'll crop 75% of the previous page, the top 75, to crop the top 75% of the previous page. And only give it the bottom 25%, and then pass that in. Now my model will see the previous page plus the current page, and then I'll feed that into the model. And now the model is basically going to see it as a continuity of the page. If that doesn't work, and I feel like that's a little too tricky, I might even stitch the page together and create a new image that actually continues it from that page.
What about that makes sense, and there may be more here. I'm curious. Maybe when I read the question, I thought it was about the like overlaying the images on top of each other and then zeroing out the pictures that were exactly the same.
That's not what I meant. What I meant about the previous pages, like sometimes data gets cut off. Like this thing is here, but it's also on page 2. Getting a model to extract data between pages is very hard. So the way that I would do that, I would try and have the model do that. I would literally pass in page 1 and page 2 together to the same prompt.
Yeah.
I'll pass in a different version of page 1, which is cropped to just the bottom 25%.
No, I mean, I guess I think Charles' question, and he had to run, but it says, I feel like I missed the page on page overlap technique to find the headers, footers, and common stuff.
Was that a separate image processing library? Oh, yes. For that, I use just OpenCV. And there's this thing in it that's called, and we'll push all the code live. There's this thing in it called image shops in the Python image library, PIL. And when you go do this, you can just do a really, really simple function. And this is all ChatGPT generated. You don't have to hand draw this. It's called image difference. And just diffs the images for you. And it produces all this stuff automatically. So you can clean up code.
Okay.
clean up
And
stuff.
that gives you like a pixel by pixel mask that you can then use to like remove or invert. Okay.
Yeah, and then you can find horizontal bands. So you can find the horizontal bands by looking at the pixels, and it literally does this code right here. It is converted to a NumPy array, finds the array, and then goes through and does that.
Gotcha. I wasn't sure if the LLM was doing some of that for you, but that's awesome.
It's really fast and really easy. It makes this trivial to go do. So like detecting headers is a non-LM problem. It's the thing I was talking about at the beginning. Don't use an LM to do like generate database IDs for yourself. Probably a dumb idea. Don't use an LM to generate common headers and footers. Probably a dumb idea. Especially when it's really easy and really cheap to do it this way.
Perfect.
Nice.
But now continuing of how we get data across multiple pages, this is what we do. We just take the images, we stitch them together, we find previous pages, and then we just crop it. And then we add it to our context window,